We'll see one more example for find out candidate key. For this given relation, the relation contains 8 attributes, that is A, B, C, D, E, F, G. These are the set of functional dependencies. Here we need to find out number of possible candidate keys for this relation. Then we'll finding the candidate keys by using the second method. First we need to observe all the right hand side attributes of the given functional dependencies. Then here the right hand side, the BC is there, CF, H is there, G, A, E, G. Then which one element which is not present at the right side is D. Here first we need to find out closure of this element, which is D plus. D determines D always, and here D cannot determine any elements. If the closure of attribute which is not present at the right side cannot determine all the elements, then we need to go for the combination of the attribute set. Then first we are trying adding A, D plus. Then we will see. Here A determines A, D determines D. Then first we will see A determines BC. And here B determines CF, H, and CH determines G. CH determines G, and E is not present in the result set. Then F determines EG. Here this is the first candidate key for this relation. AD can able to determine all the elements. Then we'll try one more combination by, suppose here if you want to find out candidate key, the D should be present. Why? Because D cannot present at the right hand side of the functional dependence. If you want to determine the D must be present in any candidate key. Here by taking D we are trying all the possible combinations. Here D must be present, then we are taking B, then we are finding D plus, closure of DD. Here BD determines always DD, and B determines CFH, CH determines G, and F determines EG, EG is already present, then A determines BC, B is already there, C. Here BD plus also can able to determine all the elements. The candidate key for this table is one more candidate key is BD. Then we will try another possible combination, CD plus. Then CD determines always CD. Here if any C determines any other elements, or D determines any other elements, no. CD plus determines only CD, which is not a candidate key. Then go for another combination, that is ED plus. Here ED determines ED, E determines A determines BC, then B determines CFH, C is also there, FH here, then H determines G. The ED can also able to determine all the elements in a given relation. We will see another combinations. Next, FD plus. Here FD determines FD. F determines EZ. Then E determines A. A determines BC. Then B determines CFS. CFS is already present. Then simply we are adding H. The FD can also determine all the elements in a given relation. FD also a candidate key. Then we will try with the next GD plus. Here GD determines GD. Here by using G we cannot determine any other elements. Here this is not a candidate key. Then next we are taking another combination. After G, H is there, HD plus. Here HD always determines HD. Then by using H we cannot determine any elements. This is also not a candidate key for this relation. Then finally these are the four possible case, four possible candidate keys for this given relations. And we can also find out all the elements by taking the another 3 element combination, that is ABD plus. But ABD plus is not a minimal super key. Why? Because the AD is always proper subset of ABD plus. Then these are the possible candidate keys for this given relations. Thank you for watching. Please subscribe to our YouTube channel and don't forget to click on bell button to get latest notifications.